Hi, my name's Connor. So today we're going to go through an example of mathematical proof.
So the example we're going to do is this one. So we're going to prove that the difference of any two consecutive square numbers is always odd. So what this means is that if we pick any two consecutive square numbers, so we could pick like 16 and 25, we could pick 81 and 100, so any two square numbers in a row, if we find the difference between them, we've got to prove that that difference is always odd. So obviously we've got to use algebra to do this. So think about it like this. So if we've got a whole number n, we'll call that m, then that means that n plus 1 is the next consecutive whole number. So that means that n squared and n plus 1 all squared are two consecutive square numbers because n and n plus 1 are two consecutive whole numbers. So the difference between two consecutive square numbers is going to be n plus 1 squared, so the bigger square number, take away the smaller square number. So what we're going to do is we're going to expand our brackets. We've got n plus 1 times by n plus 1, and then take away n squared. So expanding our brackets like this, we'll get n squared, we'll then get a plus m, we'll then get a plus n there, we'll then get a plus 1 at the end, and then take away this n squared there. So we've got n squared take away n squared, so actually these n squares just cancel out. And then we've got m plus n, which is going to give us 2m, and then plus the 1 there. Now, 2 times a whole number, that is always going to be even. So that is always an even number, because when you double any whole number, you get an even number. So pick an even number and then add 1 to it, you're always going to get an odd number. So that means that this number there is always odd. So therefore we've proved it. We've proved that the difference between any two consecutive square numbers must be an odd number.